afternoon again. And after that wonderful talk, we'll move on to our panel discussion. It's my great pleasure to introduce Amit Varma, the Kettelhut professor in the Lyles School of Civil and Construction Engineering. He'll serve as the moderator, and he'll explain to us the rules of this panel discussion then.
Thank you so much, GS. Welcome, everybody, to this panel discussion, which is titled Opportunities for Future Innovation. We heard an excellent talk from Ron Klemencic. I'm going to let Ron rest for a few minutes and introduce the rest of the panelists. Of course, we have Professor Julio Ramirez. He's the Karl H. Kettelhut Professor in Civil Engineering and the NHERI-NCO Center Director. Welcome, Julio. Akanshu Sharma. Professor Sharma is the Jack and K. Hockema Associate Professor in Civil Engineering. Welcome, Akanshu. Sogand Hasanzadeh. She is the Assistant Professor of Civil and Construction Engineering. Welcome. And Davide Ziviani. He is the Associate Professor of Mechanical Engineering and the Co-Director of the Center for High Performance Buildings. And of course, we've got Ron Klemencic, the Chairman and CEO of Magnusson Klemencic Associates. The way we're going to do this panel discussion is I'm going to request my colleagues, starting with Julio, and then Akanshu, and then Sogand and Davide, to talk for 5 minutes about some of the topics that they've selected from the opportunities for future innovation. After that, I'll request Ron to chime in. So you have 20 minutes of time where you can think about it, right? And Ron to chime in on the various innovations, and then I'll open the floor up to questions and panel discussion from all of you. Your participation is central, so we'll have about 25 minutes of discussion from the panelists, followed by 25 minutes of discussion with the audience that are attending, and we'll have all of this recorded and available on the internet for us to see. With enormous projected growth in infrastructure need, come the opportunities for innovation. We heard quite a bit about it in the presentation. There are several topics, such as embodied carbon reduction through code modification and construction activity quantification, the growing abilities of AI-based applications, performance-based structural fire design, construction automation and robotics, construction waste management, safety in the workplace, and there are many such topics to be visited. I'm going to request Professor Ramirez to initiate the discussion, and I think he's going to talk about something very interesting.
Thank you. Good afternoon, everyone. It's a pleasure to be here, and sitting next to Ron is even a bigger privilege. I'm going to make my remarks in two parts. First, I would like to make a few points, and then close with questions, which can be answered by Ron or anyone in the audience if you would like to do that. The major theme of my remarks has to do with the future of research and, in particular, the role of industry in that future. And I think Ron is, of the practitioners I know, one of the more qualified to talk about that, envisioning how research is changing. You saw some of the examples of the work that Ron has been involved with, and he can tell us very specifically what the role of industry was in each one of those projects. But I submit to you that how we are conducting research today and how we will need to conduct research in the future is not the same. And you have seen already, we have seen already some changes, whether it is the nature of the funding available to do basic research from organizations like the National Science Foundation, the National Institutes of Health, and I can go on, which fund what is called basic fundamental research. This is the research that needs to be conducted so that then that research can be transferred into practice, what we call technology transfer. I want to talk about the past 40 years or so. The change we've seen is one where federal agencies have moved in the direction of supporting large research infrastructures, meaning laboratories, computational centers, and other tools and resources that researchers need to do research at very large expenditures. I have examples, some of those that I've been involved in personally, others that I've been associated through other activities, reviewing, so forth. One is the George E. Brown Jr. Network for Earthquake Engineering Simulation, which was the first research infrastructure funded by the National Science Foundation in our field, the one that Ron is representing here today. And it basically allowed testing at scales that were not possible before. Those laboratories were built with NSF, National Science Foundation funding. So what was the difference? Those laboratories were shared use, were available to any researcher in the United States that applied for a grant to use them and was funded. They got access to that laboratory, which could have been in University of California, San Diego, Berkeley, Lehigh, you name it. What did that do? It democratized research. It allowed researchers at institutions that did not have those capabilities access to those fantastic testing laboratories. It fostered collaboration instead of so much competition. And I'm sure you already have experienced or have seen how fast knowledge grows when people collaborate versus competing. The other thing it did is it created data repositories which were available publicly to anyone on tests, computational simulation, data about hazards. One of those examples is the so-called GAGE, which is managed by EarthScope. And in few words, it allows us to measure our changing environment. Ground motions, winds, and so forth. And those data are available to researchers to use. In addition to that, those data repositories, maybe with some visioning of the future, prepare the ground for AI to come into the picture. Because one of the fundamental needs in AI is good quality data available in large quantities. And with that mode of collaboration, it went from being in my closet after a test to being in a cyber infrastructure that you could access. So now we come to the point where that funding is being cut. In that environment, the role of industry that I saw, and Ron can elaborate on that, is one where they come and partner with a researcher, whether it's to test a device, whether it's to test some new form of instrumentation, or for a proof of concept type testing. And we saw many examples of that. But the basic research was funded by NSF. Okay, that's going away. Not all, but in some form. So my question is now, first, what is the role of industry in this new environment to develop new knowledge? Second, what are the barriers in industry collaborating in research? And I think Ron alluded to one, which was we got together 16 of the largest structural firms in the United States, and we went around the room, and I am surprised. They even said they were doing something. But hey, I don't have a structural firm, so Ron can elaborate on that. So those are my remarks. Thank you.
Thank you very much, Julio. That was very helpful. Go ahead, Akanshu. Yeah.
Thank you very much, Amit. Good afternoon, everyone. And hi, Ron, again. And first of all, thank you so much for a very thought-provoking lecture. So I really enjoyed it. One of the best lectures I have heard. So thanks a lot for that. And you pointed out many, many things which have been achieved already or which are being done now or which we might expect to come in the future. One of the things you talked about is the performance-based design, right? So being a structural engineer, that is the thing which I also get more interested in. So when we talk about the seismic design over the past 50 years, we have come a long way, starting from multiplying with 10% of the weight, sorry, to now what we are doing with the performance-based design, the nonlinear analysis, and all those things. And you also talked about the future, or just what you started now with the wind, the performance-based wind design. And then you just mentioned the topic of performance-based structural fire design. And that caught my attention, because when we talk about the fire design of structures, unfortunately what we are doing, I think, is way too primitive. We are still doing this prescriptive approach. What is the dimension of the beams and the columns? If it is concrete, then how much is the cover provided to the concrete? If at all we do maximum 500 isotherm method, that's like a great deal. So we have no idea about the safety of these structures in such cases. Unfortunately, so there was a report in the 90s which showed that there are many structural collapses that happen while the firefighters are trying to extinguish the fire and then the building collapses. But the problem is that these things are still happening, right? So even if it's not just in the 90s, but even in later on in Gritzenbach fire, when the firefighters were trying to extinguish the fire and the ceiling collapsed on them because of punching shear failure and those things. I think as a structural engineer, it makes me wonder what we are doing wrong there. And as you correctly pointed out, I think the right way forward would be the performance-based approach for structural fire design as well. So my question would be, what are your thoughts? What do we need to first equip ourselves technically to get to those challenges, to solve those challenges? And then second, how can we implement it to bring it into practice? Because eventually we can do lots of research, but eventually it has to be done by the engineers in practice, right? So in seismic, we have very good examples now how it was implemented from research into practice and how it can be also taken a step further into another hazard, which is fire. So thank you very much.
Yeah, sure. So, hey again. So very, very, very nice sitting here listening to you. And I can say that you heard someone that was like very inspiring to you. I think that like our student heard a lecture that was very inspiring. And I can say in the last 5 years as a faculty, that was the first time I was sitting in a lecture and I was not falling asleep. And so able to focus. And because I think that I lost that things that after 5 minutes I cannot listen. But this time I was just the whole time a very, very interesting presentation. So I'm coming from the construction background. So I'm mainly gonna just talk a little bit about the construction technology and AI part that you touched on. So I think that all of us are on the same page that how we are at the turning point in our field. So previously we start talking about in construction industry, we are behind of manufacturing, aviation and other things. We are still behind, there is no doubt about that one. But in the last couple of years, we see the huge changes. That's what we are seeing that Ron was showing, like example of AI, example of robotics and automation that being incorporated. And it's not only the pilot testing that used to be a couple of years ago, it's actually the mainstream operational usage in our industry. But I want to get back to the AI point that he mentioned. AI meant the back office analytics, like the Excel sheet and other things, just try to do some analysis on that one. And the point that Ron mentioned is that when they get to the room with the other big firms, and then everyone thinks that, oh, this AI is just changing the whole industry, but then get to the point that what is actually happening. So I think we are all living in that world, that things that the things are changing, but we don't know how we're gonna change it. So I think that how the AI is now being used is more about automating something like an old procedure that what we were doing, right? So that's what Ron mentioned it as well, like that we don't want to see like that how to design the beam. We want to see that how we can actually transfer the process, how we can transform the whole process, how we can better understand like that the AI can use in structural, in construction, in design, or any other aspect. I think that is what is missing, and I would like to hear from you that what do you see as the main challenge in just incorporating this AI? Let's say everyone interested about this large language modeling, about machine learning and other things. What is actually will holding like companies back about like incorporating this one? And what opportunities do you see that academia can help in order to push the boundaries about the use of AI in the whole like the design, construction, maintenance, and operation of the buildings? And getting back to the robotics part. So I think that like we are moving past from the point that we are using like brake laying robots or using drone for the inspection or other things. So I think now we are on the area that we are having the integrated system of the multi-robots at the job site. But that is something that we are facing a lot of difficulties, and I would like to hear from Ron that how that, if they have experience of using multiple robots, that they are talking to each other at the job site, or if we are envisioning that is something is gonna happen later on, what concerns will come to play? And then how the workers are feeling about that one. You shows that dusty robots. I did a lot of studies with the construction companies and contractors that they are all excited at this spot robot. You probably saw it on your LinkedIn, right? That yellow dog going around. Everyone are super excited for that one. I tested the workers, and workers hate them. So just imagine that you are sitting in your office and working, and then you have that one like walking by and watching you, right? So none of us want to be watched, right? So I want to know about like that. Do you see this one as the barriers? Did you hear something from the workers, how they are feeling about this automation process? And my last point, I think that all of these changes about AI, construction, robotics, and automation needs the like academia, industry, and the government or other agencies to come together and work hand in hand. I think that's what we were seeing in the example that Ron shared, like that how they came up with the problem from industry and come with the data, come with the problem to the academia, to the labs, and then do the testing, do the modeling, and then how they work with ASC, Charles Pango Foundation, or other ones in order to have the standard in place. In order to scale an innovation, I think we need to work hand in hand in academia, industry, and the government agency. So with that one, I will stop.
All right, good afternoon, everyone, also from my side. First of all, thank you, Jess, for inviting me on this panel. And Ron, nice to meet you. I think this is the very first time that I see you, met you, and also I learn about the things that you are doing. So pretty exciting for me. I'm also the last panelist, so I have 45 minutes. Is that what it is? Just kidding. So I'm here talking about a little bit the Center for High Performance Buildings and some of the topics that we are working on and some of our perspectives. But I would like to set the stage real quick on buildings and I'm looking a little bit on numbers. I'm a mechanical engineer by training, so we look at data, right? So 40% of the primary energy in the US, roughly, maybe a little bit more than that, is attributed to buildings. The rest is industry and transportation, roughly. Out of that 40%, if you look into what consumes energy, basically half of it, it's HVAC equipment, refrigeration, water heating, anything concerning buildings. Now, these things will shift pretty soon, right? As data centers come online, hyperscale data centers, AI, computing, and things like that will require even more energy. The last number that I want maybe you to remember and reflect on is that 90% of our time is actually spent indoor, which also means that the healthy living, right, and anything concerning health inside buildings is equally important. So the Center for High Performance Buildings that was established 10 years ago, so we are celebrating our 10th year. We try to look at holistically to buildings, right? How do we tackle buildings of the future? And when we do this, right, there's multiple aspects. There's a construction, there's materials, commissioning, control, equipment that goes in it, and maybe last and not least, the humans actually will occupy those buildings. Typically, as a top-down view, we have a building, we add equipment, we add humans, we add controls, things like that. Now we are to a point where we need to look at to the bottom up. We have technologies, we have enablers. How do we build buildings actually that take advantage of those technologies? So advanced manufacturing, robotics, AI, things like that have to come with the building. It's not a retrofit. You don't go to Best Buy and buy your Ecobee anymore. Your house should be smart already from the get-go and learn preferences, learn the weather, learn anything that happens outside, utility, grid interaction, when to use energy, right, and things like that. So that's a paradigm that has to change. Our center was established, right, to bring together utilities, OEMs, material construction, envelope material, things like that. And that gives us the opportunity to really to explore those interdisciplinary aspects, right? And so, again, I'm limiting discussion to buildings, but this one can be opened up to anything else. One open challenge right now, car industry, right, back to Henry Ford, we managed to go from a one-car production to mass-produced cars, include high quality control, and get to a point that now cars basically drive autonomously. Maybe soon they will fly too autonomously, right? We don't know. Buildings, on the other hand, we are very slow, right? It takes centuries before we make the next giant leap. So the question here is, what is the next giant leap in buildings, right? How do we make that jump? And how do we re-engineer maybe buildings, right, to incorporate those technology from the get-go? So I'll stop here and back to you.
Ron, if you want to respond to any of the
Wow, there was a lot there, right? I mean, each one of them posed very deep, thoughtful, very heady questions. I could probably talk for an hour on each one of them. I'm not going to. I don't know how to choose which one to speak about. Let me start with the AI question. So it is a bit of a ponderance and a struggle. So let me try and make my point concisely. So ChatGPT is mostly fueled, right, by all of the written material on the internet. That's the database for the large language model. By the way, I learned this recently, maybe you don't know this. You know this automatic note taker thing that pops up on your Teams meeting or all of that is going out into the cosmic ether and you have no control of it. It's all in the public domain unless you turn it off, which is partly how they're expanding the large language model. So where I sign NDAs with my clients to maintain confidentiality about their projects, we must turn the freaking thing off every day because no doubt Teams and Zoom uploads it every day. And so of note, if you think, oh, that's a cool and convenient tool, it can be, but know that everything that is said or spoken about is now in the public domain. So if that's a problem to you. All right, so where am I going with all this? That's in the written world environment. I'm gonna now go down into the very narrow area of building design. So the challenge here is multifaceted in that something that's in the building world that's constantly changing, constantly evolving, are the codes and standards by which we design to. So the target is moving. So even if I had a database, a large language model populated by every building that my company has designed in the last 105 years, only the last 3 or 4 years of it is relevant because all of the rest of it is data from a prior generation of the code that's now NA. So to develop a robust enough database of common data as a baseline is very challenging. Furthermore, down this path, I know firsthand there's this organization called the Architectural Large Firm Roundtable. And it's the leading architectural practices in the country, and they meet together regularly. And about 2 years ago, they all got together and said, we're going to amass our funds. And they raised $1 million to build a common large language model that they could all use. And they were all very enthusiastic about it until they actually had to do it. And they couldn't agree on the protocol in which to populate the data because it challenged their own internal standards of how they kept their data, made their drawings, et cetera. And they didn't want to change their own internal processes to some common process. So the whole thing fell apart and it never went anywhere. Anyway, this is a problem that I think the AI populating a large language model as it relates to building design will continue to be a big problem, and I don't know how to solve it, frankly. That's why I go back to, we're shooting at the wrong targets. And the right target to me, the most clear vision I have of the right target is this using AI as a communication tool to better be able to take our analytical results, our design results, and be able to communicate those outcomes to our clients in a way in which they can truly understand it. Because right now we go into rooms and we wave our hands and we say, trust me, and we show them Ron Hamburger's sketch from 1980,
Yeah.
and that's all we have, and it's terrible. And if we were able to better communicate, whether it's seismic event or just floor vibration, for example, these things would be very, very useful. And I think that the technology to do that already even exists. It's really making the connection of how does the engineering science part of it connect to the communication graphical part of it. That would be hugely useful. Anyway, that's where I'm hoping to push. All right, so there was that one. What else should we talk about? On the funding thing, this is a very interesting question and problem. And I agree with everything you said. My unique perspective or vantage point, I say, is being in practice. What practitioners, contractors, et cetera, are interested in is things we can put into action tomorrow, which doesn't get very far in terms of funding fundamental research. I agree it's necessary and important, but business these days, our time horizon is too short for fundamental research. So industry's support of fundamental research will be very hard to come by. It's hard to come by industry support for deployable, what was the term that you used?
Research transfer.
Transfer to practice. That's what we're interested in, and some of us willing to fund. But I continue to beat the drum with my colleagues around the world on that topic, that here we are, the construction industry, contractors, engineers, architects, what have you. And as an industry, we invest very, very little in R&D. Almost nothing. Now that's to not say that we're not generous. Many, many contractors, many firms have foundations with great philanthropy supporting all kinds of noble causes. Children's Hospital, the Symphony, the arts, what have you, all very important things for the world. But very, very few, actually, only one, my company, funds research. We have to change that. And even if it's just what the thing I've been pitching to everyone I can pitch to, what I convinced my partners of finally is we take 2% of our company's annual profit, 2%, very small, 2% of our annual profit, and put it in a bucket to fund research. We're a pretty profitable company, thank you. So it ends up being a fair amount of money. But if every company did that, 2%. It's very small. But if you added it all up, it would be quite huge. Then we can really make some big changes. So I continue to beat that drum with practitioners and contractors, and I'm having some success, but it's a hard road to toe. So I remain optimistic there. As we see more output and more benefit of those investments, I think we'll see more people come to the table because they see the direct connection between here's my dollar and now I have something to work with. And the more we can show that connection, the more success we'll have in that funding. Fire design, I'm just jumping around here, sorry. On the fire design topic, you asked about barriers, I think. At least that was one of your questions, barriers. There's a lot to be said about fire design, I suppose, but the way I'm looking at it is, as I mentioned in my presentation, just another load case. It's not so frightening. And just like we do in wind design, oftentimes we work with a wind tunnel who does some testing and defines the wind demands on our building for which we design. And in seismic engineering, we often work with a seismologist who defines the ground motion. I see a future where there are fire consultants who define the fire load, the fire demand curve, assess the use of the building and the contents of the building, and develop essentially the ground motion, the thermal heat gain curve. And that's the input for our analysis, and then we go about our business and do things. And why things aren't working the way they should is because we're still in that prescriptive world of following what's written into the code and hoping that it works. And it doesn't always work. But if we did proper performance-based structural fire design, we'd know whether it works or not, and then we'd adjust. So that's a future that I see on the horizon, that we can do this. We have the technology to do it. The barrier really is the fear of the industry of doing something new, which maybe goes back to connecting that point to the construction point about these barriers. Oftentimes it's the barrier of fear, and in the case of construction, labor unions and taking work away, for example. So there's a lot of resistance to introducing robots in the field because it displaces workers. And displacing workers takes food off of people's dinner table. That's a problem. On the other hand, in the construction world, the number one biggest problem next to job site safety is workforce. There aren't enough skilled workers being trained up to fill the demand. And the only way the demand, I think, is going to get filled long-term is through robotics and through more mechanized construction, because we just won't have the people to do it. So there's a conflict there between kind of the old school of protectionism, of protecting my job as a welder, as a crane operator, versus the future of, well, there just aren't going to be that many welders and crane operators, so we have to do something different. And so we had this big issue a couple of years ago. We designed and we were going to build this very large building that required an incredible amount of welding just because of the particular circumstance, and we wanted to use field deployed robotic welding. We ran into huge resistance from the labor unions, and the negotiation started down a path of, we're not going to displace you, we're going to improve the quality of your work and your health, because we're going to retrain you to run the robot. So instead of you physically bending over, reaching up, stooping over, doing the hard labor, we're going to teach you how to program and run the robot who's going to physically do the thing. So you still have your job, but now you're managing the mechanics of it. There's hope there. Another example down that road is something that I've thought about for years. And you see them here in West Lafayette, these tower cranes, right? You think about this. There's an individual who every day climbs up the ladder 200, 300 feet in the air and sits in this little glass box with some joysticks and drives the crane and the hook. Yet we have people sitting in Nebraska flying drones in Afghanistan and doing precision bombing of things. Why do we send people 300 feet in the air in one of the most dangerous jobs in construction? Why don't we run the crane from the job shack and a joystick and a screen? It'd be a huge, huge safety improvement. I don't know why we don't do this. I understand somebody has figured out how to do this in Israel. There's a gentleman, I can't remember his name right now, but he's invented a I don't know, software and a process by which tower cranes can be driven exactly how I described. Why we're not doing this in the US, I don't know. Anyway, I'm going to stop. I keep babbling on and on and on and on. There's lots to talk about. Okay, I'll stop. Yeah, sure.
What I'll do is I'll open up the floor to the audience to ask questions, pose thoughts, etc. And I'll hand over the microphone if you or someone else will. Yeah. Go for it. It's on.
Thanks. Thanks to all of you for your great comments. You know, as I listen to you and all the advancement and the progress that you mentioned we need to have, you know, and Ron, you mentioned about embodied carbon and how we need to change our way of thinking and design and the choice of materials. The question that comes to my mind is, what about circular economy? Do we have things in place that we can design and plan for it, but do we have the material, do we have the supply chain to actually make it happen?
So it was very noisy in the back there, so I kind of heard, I think I heard a comment about circular economy.
Right, yeah.
And I guess I want to understand a little more clearly when you say those words, what do you think? What do you mean exactly?
So when we're talking about carbon sequestration, or we're talking about embodied carbon, we're talking about a choice of material and the design process that we implement. We need to have a supply chain in place that we would actually have those materials available with the properties that we need. And plus, you also mentioned demolition and construction waste. That needs to go in the economy somewhere so that it circles back and comes back to us. So that's what I'm referring to, that, how far are we in your opinion and what needs to be done?
Yeah, that's a really good question. I don't think we're very far at all. I think maybe lots can be done here. I don't have a real clear vision in my own head about what exactly that looks like. I think we still have to ponder that in its totality. I think people are working on little bits and pieces of it, but in its totality, I don't have a clear vision. I haven't heard from anybody who does. But there are parts and pieces in all of that can be worked on. Yeah, I don't know that I have like a really brilliant response to that. It's a good one. It's worth pondering. I don't even know where I want to go with that. Maybe we need to sleep on it.
Okay, I have a question. The consulting industry is changing a lot. There were many small firms located regionally and doing a great job, but not having the resources to do anything like funding the research that Julio was talking about. But that's changing, and they are consolidating. We get the bigger names. What can be done to get the consolidated firms to have a thought process similar to yours in terms of funding research?
That's a challenging question as well. Wow, you guys are really asking hard ones. One of the problems that I see with the consolidation, and this isn't true of all of these larger firms, but some of them, in fact, some of the biggest ones, are publicly traded. And so quarterly earnings drive everything. They have no long view. They have a 3-month view. And as we all know, research generally is not a 3-month horizon. So funding research and taking a longer view in the form of 2, 3, 4, 5 years, it's not in the cards. That's not how their shareholders will. The shareholders will not look favorably on them spending large sums of money with no return. That's a problem. So I don't see the big firms and this consolidation being particularly healthy for funding of research. The independent firms, we still have lots of flexibility to do these things. And I hope that we can and will. And I continue to beat the drum with my friends to do so. We're having more success. So for example, I mentioned the CURE embodied carbon thing. All right, so today, the initial tranche of work there is being funded by a consortium of organizations, but also, last count, there were 20 structural engineering practices who've all contributed to funding that. And the funding is in the range of $1,000 to $5,000 increments. But when you have 20 of them at $5,000, now I got a little bit of money. And I can go to another organization and say, I got $100,000 from 20 companies, will you help? And I get, absolutely, if there's that much industry interest in it, I'm in too, and in fact, I'll double down. So now my 100 became 200. And then I went to another organization and we say, we love what you're doing, can you make your plan, CURE, global? And I said, what do you mean by global? We want you to impact the Euro code and the Chinese code and the Indian code. Can you do it? And I said, maybe. And they said, we have $10 million, can you do it? And I said, yes, sir. How many would you like, sir? There's strength in numbers, and even if all those individuals are only putting little, very modest sums of money in, it captures the attention of the bigger money. There's the bigger money, and I sit on the board of the Pankow Foundation. We want to see industry enthusiasm, industry support, because we're interested in funding things that people care about and will use. And if we see 10 or 15 or 20 firms all contributing even very modest amounts of money, the fact that there's 20 firms all throwing $1,000 in the hat or $2,000 in the hat, that says a lot. And so it doesn't need to be, 50,000, 100,000, 200,000 from each firm. It can be $1,000. There was a NCSEA, National Council of Structural Engineering Associations, had this meeting last year. There was a room about this size. I think there was about 100 executives from structural engineering practices in that meeting, and I was invited to speak. And I don't do this very often. In fact, I've only done it once in that meeting, once. And I stood up in front of that meeting and I said, right now, I need $5,000 from every one of you, right now. You're the CEOs of your companies. There's 100 of you. I need $5,000 right now. And they all ponied up. Part of it was that the guilt factor, right? Everyone else is doing it. There's nowhere to hide. And I walked out of that room with a whole pile of money. And they all felt good about it. So anyway, there is great power in this crowdfunding if we can just activate it. And I still believe our business is a people business. So activating it live in person where I can shake your hand and look you in the eye goes a long ways, as opposed to sending you an email and hope that you don't delete me. So, all right, I'll stop. Sorry.
Hey, Ren.
Curly.
Many of the things that you've talked about, some of the panelists talked about, are about making our structures perform better. And during that, if they perform better to each and every event, they're probably going to experience many more events. Inherently, this means that the buildings are going to probably last a lot longer. So that means that they're going to be subject to degradation. Can you give us some thoughts on how we should be dealing with degradation over this extended lifetime, and how much we need to understand it in these types of buildings?
Excellent question. Again, I don't know that I have a really brilliant response to that, but I agree with your thought, your train of thought. There isn't a lot of information and data that I'm aware of as it relates to, let's take a topic, fatigue. I think we could maybe learn a bunch from our friends in the bridge world who deal with fatigue as a matter of course, but in buildings we haven't thought much about fatigue at all. Occasionally there'll be a unique building or a unique situation where we do, but generally we don't. So maybe we can start there and learn some things from our colleagues in the bridge world. The durability question maybe is the bigger question beyond fatigue as it relates to concrete, corrosion, these sorts of things. And I don't know that there's a really good answer there either, other than to say that a part of our business is we do a lot of building renovation, seismic upgrades, rehabilitations, and the buildings we're working on are all 100 years or more old. And when they were designed right then, as is today, the design life envisioned by the building code is 50 years. So they're already twice their design life, but they're really in great shape. So, to that end, maybe this whole notion of design life needs some reconsideration. And well, what are we really getting? What do we really mean? On the one hand, it goes to inform certain demand levels for wind loading and seismic loading and these sorts of things. But as it relates to just everyday gravity, maybe something else needs to be done or said about it. That's a really interesting, heady question I don't know the answer to. I will say we're working on a number of these very ambitious projects, mostly in the Middle East, and they're so ambitious and they recognize that these buildings have 50-year design life for what they're trying to build makes no sense. Some of these like super tall buildings, like we all know the Burj Khalifa in Dubai, 828 meters tall, having a 50-year design life, it doesn't make any sense for a building of that scale. So for better or worse, right, most of those buildings are targeting a design life of 100 years. Why? Because it's twice 50. But in reality, that structure, it might be there 1,000 years. It's plausible. The pyramids, right? They've been there a long time. So it's plausible. The parts of the building that are more frayable, the exterior facade and the services inside the building, the air conditioning systems and whatnot, there is where service life maybe needs to be thought about much more in depth than the structure. Because, the structure, we have a saying in our company, I think it's not just in our company, it's in our business, right? If a structure survives construction, it's going to be there a long time. Because construction usually is the most critical loading that the building will see is while it's being built. And if it lives through the construction process, it's probably going to be there for quite a while. So on the construction, on the structural side of it, in particular, if the building is in a controlled environment forevermore, maybe I'm not too worried about it. It's going to be there a long time. If it's an exposed environment, then I'm a lot more worried because now we're back into the bridge world or the offshore oil rig world where they faced these challenges and needed to more directly. So learning from our colleagues in these other areas is, I think, quite helpful.
Springboarding off of that a little bit, one of the things that I've done is bring facility maintenance to our program. And the work that I do is associated with mostly higher education universities and how they maintain campuses. And they've been using fault detection diagnostics to handle HVAC systems and determine whether they need to make some changes to conserve energy. Are there other opportunities that we might consider that would install fault detection diagnostics in the structure or in other parts of the facility?
Yeah, I think there's lots of room for growth there. And it's not really a new, I'm going to use the word technology. That's not quite the right word. Let me say this differently. 25 years ago, we worked on the design of what's called the Letterman Digital Arts Center. It's George Lucas's headquarters in San Francisco. And then 25 years ago, their charge of us, the design team, was I want to manage my entire campus and all of its operations through a single live computer model, where all of the data for all of the, I'll call it Internet of Things, all the equipment, the elevators, the air handling units, the pumps, everything was inputted into the system and spoke to the system so that they could manage and monitor the whole building, both from an operational side and a maintenance side. And this was done 25 years ago. So that's like not new, but it's not, I wouldn't call it commonly deployed. There's an avenue for lots more growth of making this more commonly deployed. And a lot of these things, I think that there's this fork in the road of if we can show, in this case, building owners, the value to them of having such a tool, and value meaning cost efficiency, energy consumption reduction, what have you, whatever is the value proposition, show them that clearly so that then they get it and they're willing to invest to do it. To me, that's the better way to go. Or if for whatever reason we can't, but it's just the right thing to do for the world, that's where the mandates come in and the legislation and the government says you must. And then we can invoke change. I don't like that as well. I'm kind of in favor of let the market tell you what's important. But that's the fork in the road. You can get to the end both ways, which is the better right way. I like this idea of being able to tell the value story and let the market say, yes, we believe, we'll buy. This was my story with performance-based seismic design. When we started that, nobody really knew what it was, but very quickly everyone learned of the value that it provided, and then everybody wanted one. And how it became common practice was our firm, MKA, started winning every project, and our competition was going out of business. They couldn't win. And so very quickly they had to learn and adapt and change and develop the practice. And so now everybody does it because the value was clear and obvious and everybody needed to do it. So that's really where the fulcrum of all this is being able to show clearly the value that is offered by these things. So.
It's about 3:10. I think we've maybe one final question from the students, if there is one. Okay.
Hey, sir. You mentioned being confident that during the weather event in Japan that your building was fine. Do you feel like there's value to that kind of information? And if so, how could we improve that value going forward?
Yes, so there's great value in having, call it building health monitoring. The challenge that has been and remains is our building owner client types are so afraid of the data somehow being used to discredit their building in some way by the market that they oftentimes, in fact, with regularity won't allow us to share the data. We have the data, and as long as we keep it to ourselves, and if there's anything to talk about, we got to call them. But for us to publish it in a paper, it's pretty rare. And it's because they're so afraid that their competing building will somehow spin the data to say, well, that building's terrible because it swayed 3 inches in the wind. You don't want to go there, it's unsafe, which is total bullshit. But that's what they're afraid of. So, I'd love to monitor every building, but, we can't, we don't. The buildings where we've been successful in monitoring them are buildings in which we have deployed damping systems. And we've convinced the client, in order for us to manage the performance of the damping system, we have to have the data. Because without the data, we can't manage the performance. And so then they've agreed, and so all those buildings where we have dampers in Chicago, we have 3 buildings monitored. The building in Hong Kong I showed you, we have 2 in Hong Kong. Anyway, around the world, maybe I have a dozen buildings that have monitoring systems in them. And I have all the data. In fact, it's on my phone. I could show it to you. I got an app. You want to see the building in Hong Kong? I got an app. It'll tell you exactly how much it's swaying right now, live. But I can't show it to you unless you sign an NDA.
So what type of sensors there were?
I'm sorry?
What types of sensor are
They're very, very simple accelerometers, basically. They're very inexpensive, like less than $50, and a laptop. So to put the entire sensor system in the building, and deploy a whole array of these things, we can do the whole thing for a couple $1,000. It's not expensive at all. And we used to, this is funny, but it's true. Back in the day, we'd buy the parts at Radio Shack. Well, Radio Shack doesn't exist anymore, so we buy them online. But they're very inexpensive, and with a laptop and an internet connection, up you go. So, and then we've got live data, and it's very useful. But unfortunately, we're precluded from sharing most of it. So I don't know how to solve that problem. I'd like to, but I don't know how.
All right. I think we've had a great panel discussion. I want to thank the panelists, and I want to thank Ron, and then I want to thank all of you students, faculty, and staff for participating. And I want to thank everybody who's helped set this event up. Thank you very much.